Hi, now we're ready to talk about what's different if you don't know the population standard deviation, you only know or can figure out the standard deviation of your sample, and so you have to do a t-test. So that's where we don't know sigma, just S, the standard deviation of the sample. So here's what we have to do differently. If you're using a graphing calculator, like a TI-84 or something, the only thing you have to do different is select t-test instead of z-test. And then when it asks you to fill in the numbers, one of the numbers it asks you for will be S instead of sigma. Everything else is going to work exactly the same as what we've been doing. If you're going to be using that Excel spreadsheet that I put up on Canvas, make sure you go to the sheet or tab labeled t-test, and it will have a space where you put in a value for S, and other than that, everything will work exactly the same. Now, if you are trying to do things yourself without any special calculator functions or software or apps or anything like that, then it gets a little more complicated. So here's the by hand method. It's going to involve using table F, which is the one about the t distribution. So here's how that would work. You would calculate the test statistic t using the formula t equals x bar minus mu over sigma over s, divided by the square root of n. It's an s instead of a sigma, but other than that, it's the same formula I showed you last time. Then you go to table F. You look at the row of the table that corresponds to your degrees of freedom, which is your sample size minus 1. Whatever n is, n minus 1 is your degrees of freedom, and that tells you what row to look at. Then look across that row and find two numbers in that row that your calculated t is between. Then go up to the top of the columns that those numbers are in and look in the row labeled one tail. If you're doing a left or right tailed test, remember that's if you have a less than or greater than sign in your alternative hypothesis, or two tails if you're doing a two-tailed test. That would be if your alternative hypothesis has a does not equal to sign. So the p-value is somewhere between these numbers. You can't tell what it is exactly, but you can tell if it's small enough to be less than your alpha or big enough that it's greater than your alpha. Now that's all kind of complicated, but I will show you how that works when we work through an example or two. So here we go with an example. In order to increase customer service, a muffler repair shop claims its mechanics can replace a muffler in less than 12 minutes. A time management specialist selected 6 repair jobs and found their mean time to be 11.6 minutes. The standard deviation of the sample was 2.1 minutes. Now right away, notice it said the standard deviation of the sample. That's our clue that we're doing a t-test instead of a z-test. We only have a number for the standard deviation of the sample, not for the standard deviation of the whole population. Okay, at alpha equals 0.025, is there enough evidence to support the shop's claim? So step 1, state the hypotheses and identify the claim. What's the claim? Well, they claim they can replace a muffler in less than 12 minutes. So in terms of mu, that would be that mu is less than 12. Mu would stand for the average time to replace a muffler. And this is this the null or is this the alternative hypothesis? It doesn't have an equal sign in it, it has a less than sign, so this would be the alternative hypothesis, H1. So in that case, what is the null hypothesis? What's H0? Well, it's exactly the same thing, but with an equal sign. mu equals 12. Okay, step 2, compute the test value. No matter what method we use, we have to know what numbers to put in. So mu is 12, the number in the hypotheses. X bar is 11.6. That's the sample mean. So for those 6 repair jobs that made up the sample, the mean time was 11.6. That is less than 12. The question is that enough less than 12 that we really know that they can do it in under 12 minutes in general, not just for those particular 6 repair jobs that might have taken less time than average. You don't know. So S, the standard deviation of the sample, was 2.1 minutes, and N, the sample size, was 6. That's how many repair jobs there were in the sample. So if we calculate the test statistic directly from the formula ourselves, we plug these numbers in, and it's 11.6 minus 12 divided by 2.1 over the square root of 6. And that comes out to be negative 0.467. Let me show you what that looks like going into the calculator. So we put it in as parenthesis 11.6 minus 12, close parentheses, divided by parenthesis 2.1 divided by the square root of 6. And that does come out as negative 0.4665 and so on. So about negative 0.467. Now, if we were using the special t-test function, we would push the stat button, go over to tests, select t-test, make sure we're on stats, and put in the numbers. The mu is 12, the X bar is 11.6, the S is 2.1, and the N is 6. And the alternative hypothesis does have a less than sign. It is that mu is less than this number 12. And then we calculate, and it tells us t equals negative 0.4665 and so on. And it also tells us that p is 0.33 something. So the p value is about 0.33. If we're using the Excel spreadsheet, I would go to the tab labeled t-test. And I would put in those numbers into those yellow boxes. The mu sub 0, the number in the hypotheses, was 12. The S, the sample standard deviation, was 2.1. The X bar, the sample mean, was 11.6. And the N, the sample size, was 6. And H1 is, mu is less than 12, so the p-value is 0.33 and so on. Now suppose we calculated this ourselves from the formula. We got that t was negative 0.467, and we wanted to work out the p-value for ourselves from the table. Here's how that would work. We would go to table F. Remember, that's the one that looks like this. It says the t distribution. Our sample size was 6, so degrees of freedom would be 5. So we're looking at the row of the table where degrees of freedom is 5. Now look across that row of the table and try to see where that test statistic would fit. Or in this case, the test statistic was negative, but we're interested in the absolute value. It was, well, the absolute value was 0.467, where does that go? It's not between 4.032 and 3.365. It's not between that and that. It's not between that and that. It's not between 2.015 and 1.476. In fact, it would be over here. It would be less than the 1.476. So it's clear over here somewhere. Now go up to the top to where it says one tail alpha. One tail because we're doing a one-tailed test, and I know that because my alternative hypothesis had a less than. We're only interested in a difference in one direction, so this is a one-tailed test. So if I had gotten a test statistic that was between 1.476 and 2.015, for example, which I didn't, but if I did, that would tell me that the p-value was somewhere between 0.10 and 0.05. If I had gotten a test statistic, a t, that was somewhere between 3.365 and 4.032, then I would know that my p-value was somewhere between 0.01 and 0.005. What actually happened was that my t was, well, the absolute value of it was 0.467, which was over here. And so from that, I know that my p-value is over here somewhere. It's greater than 0.10. Now, the calculator and the Excel spreadsheet told me that it was 0.33. So from the table, I don't know exactly what it is, but I do know that it's pretty big. It's bigger than 0.10. And that's enough for me to do step 4. The p-value is 0.33. All we know from the table is that it's greater than 0.10, but that's enough to compare it to alpha. So for step 4, where we make the decision to reject or not reject the null hypothesis, the p-value was 0.33, or at least something greater than 0.10. Alpha is 0.025. And since the p-value we got was greater than alpha, we say do not reject the null hypothesis. We're not saying we accept it or support it or anything like that. We're just saying we do not reject it. There's not enough evidence to reject it. Kind of like when there's not enough evidence to prove that the defendant is guilty. We're not saying for sure we know he's innocent. We're just saying we don't have enough evidence to prove beyond a reasonable doubt that he's guilty. So here we don't have enough evidence to prove beyond a reasonable doubt that the null hypothesis is false. We don't reject it. We don't rule it out. So what does that mean in step 5? Well, we did not reject the null hypothesis. The claim was the alternative hypothesis. So there is not enough evidence to support the claim. Not goes with not reject the null, so not enough evidence to support. And we were talking about supporting the claim, or in this case, not supporting it, because the claim was the alternative. So not rejecting the null means not supporting the alternative, which was the claim. There is not enough evidence to support the claim that they can replace a muffler in less than 12 minutes. We're not saying that's wrong. We're not saying they can't do it in less than 12 minutes. We're just saying we didn't find enough evidence to support that claim. We only looked at 6 repair jobs after all. And those 6 repair jobs came in at a little less than 12 minutes, not a lot. So maybe they can do it in less than 12 minutes. Maybe they can't. If we went back and did a bigger test with a lot more than 6 repair jobs, then maybe we would get enough evidence. Or maybe it would turn out that with a bigger sample size, that the average time wasn't less than 12. But just from what we have here, we don't know. There's not enough evidence to be able to say and be reasonably sure that the average time for all their muffler repair jobs is less than 12 minutes. Okay, back in the next part with another example. See you then.